Peace be upon you. Welcome to all my students in prep 3 with you, Mr. Muhammad Omar. Today's lesson about equality of two algebraic functions. So, in this lesson, we have two rules. The first rule is reducing the algebraic fractions. It says that the algebraic fractions in its simplest form if there are no common factor between its numerator and denominator. So from the previous, to reduce the algebraic fraction, we should follow three steps. Number one, factorize each of numerator and denominator perfectly. Number two, identify the domain of the algebraic fraction before removing the common factor between the numerator and denominator. Number three, remove the common factor between the numerator and denominator to get the simplest form of the algebraic function. This is rule number one. Rule number two, equality of two algebraic fractions. It says that the two algebraic fractions in1 and in2 are equal if the two following conditions are satisfied together. Number one, the domain of n1 equal the domain of n2. Number two, n1 of x equal n2 of x. For each x belong to the common domain. To understand, let's take example. Example number one, it choose the correct answer. Number one is the domain of n1 such that n1 of x equal 5 over x minus 8 equal the domains of n2 such that n2 of x equal x minus 3 over x minus k. We know that to make the two fractions having the same domain, it must be the set of zeros of the denominator of the first fraction equal the set of zeros of the denominator of the second fraction. And here, when we put x minus 8 equals 0, then x equal 8. Also, if we take x equal negative 8, then x minus 8 equals 0, then x equal 8. So the common domain between them is r difference 8. Okay, now the result of k equal negative 8. Okay, number two, if n1 of x equal x power 2 minus 4 over x minus 2 and n2 of x equal x plus 2, then n1 equal n2 when they have the same domain, which is, we know that the domain of the first fraction is r difference 2, r difference the set of zeros of the denominator, and the domain of the second function is r. This is polynomial function, and the intersect between them is what? Is r difference 2. So the result is r difference 2. Another page, number 3. If n1 of x equal 1 over x minus 3 and n2 of x equal 1 over 3 minus x, then n1 not equal to n2 because what is the reason? Letter A, n1 of x equal n2 of x, that's wrong. Letter B, the domain of n1 equal the domain of n2, that's wrong also. Letter C, n1 of x not equal to n2 of x, that's right, because the n1 of x and n2 of x having the different sign. Okay, say problems. Reduce each of the following algebraic fractions to the simplest form to showing the domain of each of them. Okay, to answer each of the following example, first of all, we should follow the previous three steps. This is three steps. Number one, factorize each of the numerator and denominator. Number two, identify the domain. Number three, remove the common factor. Okay, let's solve it. The first example, n of x equal to x plus 8 over x plus 4. N of x equal to x plus 8 over x plus 4. First of all, let's factorize the numerator by taking highest common factor. The highest common factor is 2, and then 2x divided 2 equal x, and 8 divided 2 equal 4. So the remainder is x plus 4. And in the denominator, x plus 4 also, this is 2 common factor. Then before removing, we get the domain. The domain of the denominator equal what? Equal r difference the set of zeros of the denominator, and the set of zeros of the denominator x plus 4 equals 0, then x equal negative 4. Then let's put n of x in the simplest form, then n of x equal 2. This is the value of n of x. Okay. Okay. Example number 3. In each of the following, prove that n1 of x and n2 of x are equal for all values of x, which belong to the common domain, and find the domain. Okay, this is number 1. n1 of x equal 4x minus 8 or minus 9 over 6x minus 9, and 2 of x equal to x power 2 plus 3x over 3x. Okay, this is 2 fraction, and we need to get the equality between them. And we know that this is the rule of equality of 2 algebraic fractions. The first rule is the domain of n1 equal the domain of n2, and second, n1 equal n2. Okay, let's solve the first example, n1 or n of x equal to x minus 8. Okay, let's factorize. This is example. We take 2 as a common factor, then the remainder is x plus 4 and x plus 4 in the denominator. Also, let's factorize. This is expression. Okay, another example, sorry. This is example. Okay, let's factorize the first example. This is difference between 2 square. And to factorize the difference between 2 square, open 2 brackets, and 2x times 2x, 3 times 3, one positive and the other is negative, over, we take 3 as a common, then the result is 2x minus 3. Okay, this is the first fraction, and the second fraction, we take x as a common factor, then the remainder is 2x plus 3 over 3x. 2x plus 3 over 3x. First of all, let's get the domain of the 2 fractions. We know that 2x plus 3 or 2x minus 3 over 2x minus 3, they are cancelled. And number 2, x and x also, they are cancelled. Then the remainder is 2x plus 3 over 3 and 2x plus 3 over 3. We notice that n1 of x equal to n2 of x. And now we prove the first one. Okay, and you can solve another example. And now we are finished our revision in this lesson. I hope everyone is benefit, and see you later in other videos.